This video tutorial is showing how to monitor Mopra for LBA usage. All of the observing is done from the Big Rock 1 VNC session using the normal ATNF VNC password. I'll start with an overview of the main Windows and virtual desktops. All observing is done from the VLOBS window, usually running in the top right hand corner. The same window, there's AT Drive Mon, which gives you a overview of what the antenna is doing. There is the AT Test program, which allows you to interact with the telescope backend, doing things like setting the attenuation, stowing the antenna. And there is a monitor instance, which gives you an overview of the IF power levels through the system. On other virtual desktops, there is the CDisco program, GUI, for recording the data. There's the ATNF DAS for controlling the samplers, and there are some miscellaneous monitor windows for monitoring the weather. So the main antenna control is from the VLOBS program. I'll just stop that recording now. If it normally will be running, if it is not, you just run VLOBS from a Big Rock terminal. Sometimes it fails to start and fills the screen with garbage. If it does that, just try again. And if that fails, try again and try again until it works. When it has been particularly bad, it can take 10 to 20 times to start, but usually it is fine. If there is no schedule running, it beeps once a second as a warning, because the antenna is idle. To load a schedule, you just type File, the name of the schedule, which is normally then just the name of the experiment, and then type Start to start the experiment. It will skip to the right point and start slewing the antenna to the current scan. Don't use the track command, that doesn't work properly. The VLOBS window tells you what the current scan is and what the next one. While observing, you should just monitor this to check that that is cycling through scans as you expect and it is on the current source. The other thing this shows on the VLOBS window is the current TSYS. Now normally these all should be set to a sensible value. You can see one value is 0, which is a problem, but I'll explain later that's an issue with the current setup. While you're recording, one of the things you should check is that the IF levels for the system are okay. The GTP is the current power level for the 4 IFs, the 2 frequencies and 2 polarizations. A1 and B1 is the first frequency, A2 and B2 is the second frequency, and A and B are the 2 polarizations. The GTP value should be nominally between about 1 and 3.5, so there is a fair range, and SDO should be approximately the same. You can see for the third value, the GTP value is too high, which means SDO is 0 and the TSYS estimation is failing. So normally you would need to adjust for this, and I'll explain later why this isn't working. You should, while you're observing, also monitor the LBA DAS windows. This first slider gives you indication of the IF power level coming into the system. All of these sliders should be approximately mid-range. As long as the sliders are actually not hitting one edge of another and the DAS is complaining by beeping and going red once a second, the values are actually okay. It adjusts for the attenuation values. But as an example, at the moment we can see the first IF, the value is slightly high, so we need to adjust the attenuation. Normally we would only do this at the beginning of the experiment, and it's usually okay. Though at some of the higher frequencies, when the weather changes, you may need to adjust. So then we go to the AT Test program, click on the Attend tab, and we want to add some attenuation. So normally you would just adjust the fine attenuation. I'll add 1 dB of power, set that, and we see that the power level has come down a little bit. We could even add a little bit more. And it's quite a nice value now. Again, normally you would during an experiment you'd only adjust this if it is hitting one extreme or the other, or it's continuously been very high for quite a while. Otherwise you're wasting your time. So at the moment, even though the DAS here on this third IF is roughly centered, we can see that the GTP value is too high. In this case, we can add a little attenuation. It usually takes about 10 to 20 seconds or less now. So now the GTP is coming within range and the T-sys is recovered, and the DAS is low, but it's in the acceptable range. Because of this problem with the two needing slightly different power levels, you may sometimes find that the DAS is off scale and you need to have the GTP wrong. If the DAS is complaining, you should always prioritize having the DAS power level correct rather than the T-sys. But at the moment, both are within range and it is working. While you're running, you should just keep an eye on AT drive mon that the antenna is tracking. There is not a drive error or the antenna is idle. That obviously indicates a problem. And obviously it'll be slewing at times, and should check that it actually does come on source occasionally. The other issue you need to monitor is the weather. If the wind is consistently very high, the antenna will hardware wind stow, so you normally don't need to worry about that, and then it will automatically recover at the end. You should keep an eye on lightning. At the moment there is no strikes at all. If the lightning threat is telling you to stow the antenna, you probably should stow the antenna manually, or if you can see that there is a lot of far strikes that are getting closer, or if you're watching one of the weather monitors and there's a storm cell approaching rapidly, then you should manually stow the antenna. To do that, you need to stop the antenna from VLOBs. We'll go idle, hopefully. Then from AT test, you go to the stow tab and click the stow button. At the end of an observing session, you would do the same thing. You can type stow in VLOBs, but it doesn't work. It doesn't ever complete the operation properly. So always stow from ATest. If you're recovering from this situation, you just type start in VLOBs. You don't need to use an unstow command. We'll just resume now by typing start in VLOBs. Recording, like the rest of the main 18F antennas, is done during the C-Disco program. There's a separate video tutorial on using that. But briefly, as a summary, you just put the antenna experiment name in, the recording time, you set the recording mode, bandwidth, number of channels, choose the disk you want, you submit the changes, then just checking that all those values are through, then you click the start immediate recording or start delayed recording on the main window, and once the recording is running, just monitor the system through the recording status window. It takes usually about 30 seconds before the first update comes through. You should just check that the channel statistics, sample statistics look reasonable. The big buffer value is around 100. There are no significant PPS errors. And also check regularly that the last file is approximately the current UT time and is changing. Occasionally the system crashes, indicates it's still recording, but no new data is being recorded. So if this is a very old time, you know that the system has crashed. You should just check this once every 20 to 30 minutes on top of the watching on the web RecMon page. Now, during the VLBI observing, typically what you would do is every 20 to 30 minutes just come back, check that VLOBS is still running. Occasionally it crashes. Check that there aren't any drive errors. Check the IF levels are sort of within range. The TSYS values are all good or sensible. The DAS values are correct, and we can see now that the DAS has actually gone out of range, and this is a problem. If system beep is set up correctly on your VNC session, you should be hearing a beep every couple of seconds. So in this case, I'm actually going to remove some attenuation. Hopefully that brings it, so that's now brought it back into range, and the GTP is just within range, so the TSYS is still being recovered. And the last thing you need to monitor is just keep an eye on the weather, particularly if you can see that the wind is coming up or there is a lightning about. And that's pretty much all you need to do for Mopra, as well as monitoring as normal the record and monitor